The 2002 National Electrical Code, or NEC, introduced a requirement for main breakers in remote panels in specific scenarios. This requirement primarily affects installations where the main electrical panel is located in a garage or another structure detached from the main dwelling unit. To understand the necessity for this requirement, we need to examine Article 408.16b of the NEC. Article 408.16b specifically addresses dwelling units where the main disconnecting means, which is typically the main breaker or main switch in the service panel, is located in a garage or other detached building or structure not directly attached to the dwelling unit itself. In these cases, the code mandates that each dwelling unit must have a readily accessible disconnecting means located within the dwelling unit. This disconnecting means must be capable of disconnecting the entire dwelling unit from all ungrounded conductors. Ungrounded conductors are the hot wires that carry electrical power from the panel to the various circuits within the house. The intent behind this requirement is to provide a means of quickly and easily disconnecting electrical power to the dwelling unit in the event of an emergency situation. A common example of such an emergency is a fire in the garage. If a fire were to break out in the garage where the main electrical panel is located, it may become difficult or impossible for occupants or first responders to safely access the main panel to shut off the power to the entire house. This situation could pose a significant risk to firefighters attempting to extinguish the fire, as they could be exposed to live electrical conductors. Furthermore, it could delay the process of shutting off power to the building, potentially exacerbating the fire and increasing the risk of property damage or personal injury. By requiring a readily accessible disconnecting means within the dwelling unit itself, the code ensures that occupants or emergency personnel can quickly and safely de-energize the electrical system in the house, even if access to the main panel in the garage is compromised. This disconnecting means is typically implemented as a main breaker installed in a subpanel located within the dwelling unit. This subpanel acts as a remote distribution point for the electrical circuits in the house. The main breaker in the subpanel serves as the local disconnecting means required by Article 408.16b. There are several important considerations regarding the selection and installation of this main breaker in the remote panel. Firstly, the main breaker must be rated for the maximum load of the subpanel. This means that the breaker's amperage rating must be sufficient to handle the total current draw of all the circuits connected to the subpanel. To determine the appropriate breaker size, an electrician will perform a load calculation based on the anticipated electrical demand of the dwelling unit. This calculation takes into account factors such as the square footage of the house, the number and type of appliances, and the lighting load. Secondly, the main breaker must be readily accessible to occupants of the dwelling unit. This means that the breaker should be located in a place that is easy to reach and does not require the use of tools or ladders to operate. The breaker should not be obstructed by furniture, stored items, or other obstacles that could impede access. Thirdly, the main breaker should be clearly labeled to indicate its function as the main disconnecting means for the dwelling unit. This will help occupants and emergency personnel quickly identify and operate the breaker in the event of an emergency. The labeling should be durable and easy to read even in low light conditions. It is important to note that Article 408.16b only applies to dwelling units where the main disconnecting means is located in a garage or other detached structure. If the main panel is located within the dwelling unit itself, such as in a basement or utility room, this requirement does not apply. In these cases, the main breaker in the main panel serves as the primary disconnecting means for the entire dwelling unit. Furthermore, the requirement for a main breaker in a remote panel is not retroactive. This means that it only applies to new installations and alterations performed after the 2002 NEC went into effect. Existing installations that were compliant with the code at the time they were installed are not required to be upgraded to meet the new requirement. However, if an existing installation is substantially altered or expanded, the new work must comply with the current code, including the requirement for a main breaker in the remote panel if applicable. It's also important to differentiate between a main breaker and a backfed breaker. While both can serve as a disconnecting means, they are installed and wired differently. A main breaker is typically installed at the top of the panel and is designed to protect the entire panel from overcurrent. A back-fed breaker, on the other hand, is installed in a standard breaker slot and is typically used to feed power from a generator or other alternative power source into the panel. When using a back-fed breaker as a main disconnecting means, it must be secured in place with a listed locking device to prevent it from being accidentally disconnected. In summary, the 2002 NEC requirement for a main breaker in remote panels is intended to enhance safety by providing a readily accessible means of disconnecting electrical power to a dwelling unit in the event of an emergency. This requirement applies specifically to installations where the main electrical panel is located in a garage or other detached structure. The main breaker in the remote panel must be rated for the maximum load of the panel, be readily accessible, and be clearly labeled. This regulation, detailed in Article 408.16b, ensures that occupants and first responders can swiftly de-energize the electrical system, minimizing risks associated with fires or other hazardous situations. Now, let's explore some additional scenarios and considerations related to this NEC requirement. Firstly, consider a situation where a homeowner adds a detached garage to their property after the initial construction of the house. If the homeowner decides to relocate the main electrical panel to the new detached garage, then the requirement for a main breaker in a remote panel within the dwelling unit would apply. The homeowner would need to install a subpanel inside the house with a main breaker that can disconnect all ungrounded conductors serving the dwelling. Secondly, let's examine a multi-family dwelling unit, such as an apartment building. In these buildings, it is common for each apartment to have its own electrical panel located within the unit. The main service panel for the entire building is typically located in a common area, such as a basement or electrical room. In this scenario, the requirement for a main breaker in a remote panel would not apply, as each apartment already has its own electrical panel with a main breaker located within the dwelling unit. However, if the main service panel for the entire building were located in a detached garage or other structure, then each apartment would need to have a disconnecting means located within the unit, as per Article 408.16b. Thirdly, it is important to understand the difference between a disconnecting means and an overcurrent protection device. A disconnecting means is a device that is used to isolate an electrical circuit or piece of equipment from its power source. An overcurrent protection device, such as a circuit breaker or fuse, is a device that is designed to protect an electrical circuit from excessive current flow. While a main breaker can serve as both a disconnecting means and an overcurrent protection device, these are distinct functions. The requirement for a main breaker in a remote panel is primarily focused on providing a disconnecting means for safety purposes. The overcurrent protection function is secondary, although it is still important to ensure that the breaker is properly sized to protect the panel and the circuits it serves. Fourthly, it is crucial to ensure that all electrical work is performed by a qualified and licensed electrician. Electrical work can be dangerous, and improper installation can lead to serious injury or property damage. A qualified electrician will be familiar with the NEC and other applicable codes and regulations and will be able to ensure that the installation is safe and compliant. The electrician will also be able to perform a load calculation to determine the appropriate size for the main breaker in the remote panel. Fifthly, when selecting a location for the subpanel with the main breaker inside the dwelling unit, it is important to consider accessibility and aesthetics. The subpanel should be located in a place that is easy to access in an emergency, but also blends in with the surrounding decor. Common locations for subpanels include utility rooms, basements, and closets. The subpanel should be mounted securely to the wall and should be protected from physical damage. Sixthly, it is important to periodically inspect the electrical panel and breakers to ensure that they are in good working order. Look for signs of damage, such as corrosion, overheating, or loose connections. Test the breakers periodically to ensure that they trip properly when overloaded. If you notice any problems, contact a qualified electrician to perform repairs. Seventhly, consider the impact of future electrical loads when sizing the main breaker in the remote panel. If you anticipate adding additional circuits or appliances in the future, it is wise to select a breaker with a higher amperage rating to accommodate the increased load. This will prevent the breaker from tripping frequently and will avoid the need to replace the breaker later on. Eighthly, when installing a subpanel with the main breaker, it is important to follow all manufacturer's instructions and recommendations. The manufacturer's instructions will provide detailed information on how to properly install and wire the panel and breakers. Following these instructions will ensure that the installation is safe and reliable. Ninthly, it is important to understand the grounding and bonding requirements for subpanels. A subpanel must be properly grounded to provide a safe path for fault current to flow back to the source. The grounding electrode conductor must be connected to a grounding electrode, such as a ground rod or water pipe. The subpanel must also be bonded to the neutral conductor to ensure that there is no voltage difference between the metal parts of the panel and the neutral conductor. Tenthly, consider the use of arc fault circuit interrupters, or FSIs, and ground fault circuit interrupters, or GFCIs, in the subpanel. FSIs are designed to protect against fires caused by arcing faults in electrical wiring. GFCIs are designed to protect against electric shock caused by ground faults. The NEC requires the use of FSIs and GFCIs in certain locations, such as bedrooms, bathrooms, and kitchens. In summary, the requirement for a main breaker in a remote panel is an important safety measure that helps to protect occupants of dwelling units from electrical hazards. By understanding the requirements of Article 408.16b and following best practices for electrical installation, you can ensure that your electrical system is safe and compliant. Remember to always consult with a qualified electrician for any electrical work. The 2002 NEC introduction of Article 408.16b brought significant changes to electrical safety standards, particularly for dwelling units with main disconnecting means located in detached structures like garages. This section delves into the nuances of this code requirement, providing a comprehensive understanding of its purpose, application, and practical implications. At its core, Article 408.16b addresses a critical safety concern: the need for a readily accessible means to disconnect power to a dwelling unit in emergency situations, especially when the main electrical panel is not located within the dwelling itself. Imagine a scenario where a fire erupts in a garage housing the main electrical panel. Access to the panel might be compromised, preventing occupants or first responders from quickly shutting off the power. This delay could exacerbate the fire, endanger lives, and hinder firefighting efforts. Article 408.16b mitigates this risk by mandating a disconnecting means within the dwelling unit capable of cutting off all ungrounded conductors. This requirement necessitates the installation of a subpanel inside the dwelling, equipped with a main breaker that serves as the local disconnecting means. This subpanel effectively acts as a remote distribution point, allowing for immediate power disconnection in emergencies. Several key considerations are vital when implementing this code requirement. Firstly, the main breaker in the subpanel must be appropriately rated for the maximum load of the panel. This ensures that the breaker can handle the total current draw of all connected circuits without tripping prematurely. Electrical professionals conduct load calculations considering factors like the dwelling size, appliance types, and lighting needs to determine the correct breaker size. Secondly, the main breaker must be readily accessible to occupants. It should be located in an easily reachable area, free from obstructions, and not requiring tools or ladders for operation. Accessibility is paramount for quick power disconnection during emergencies. Thirdly, clear labeling is essential. The main breaker should be prominently marked as the main disconnecting means for the dwelling unit. Durable, easy-to-read labels ensure that occupants and emergency personnel can quickly identify and operate the breaker, even in poor lighting conditions. It's crucial to note that Article 408.16b applies specifically to dwelling units with main disconnecting means located in detached structures. If the main panel is within the dwelling, such as in a basement, this requirement doesn't apply. Furthermore, the code isn't retroactive. It applies to new installations and alterations after the 2002 NEC effective date. Existing installations compliant with previous codes aren't required to be upgraded unless substantial alterations are made. Understanding the distinction between a main breaker and a backfed breaker is also important. While both can function as disconnecting means, their installation and wiring differ. Main breakers, typically at the top of the panel, protect the entire panel from overcurrent. Backfed breakers, installed in standard slots, often feed power from generators. When using a backfed breaker as a main disconnecting means, it must be secured with a listed locking device to prevent accidental disconnection. The purpose of Article 408.16b is to enhance safety by providing a readily accessible way to disconnect power in emergencies. Compliance involves installing a properly rated, accessible, unlabeled main breaker and a remote panel within the dwelling unit. This ensures that occupants and first responders can quickly de-energize the electrical system, reducing risks associated with fires and other hazardous situations. Now let's explore practical scenarios to further illustrate the application of this code requirement. Consider a homeowner adding a detached workshop to their property. If the main electrical panel is relocated to this new workshop, the requirement for a main breaker and a remote panel within the dwelling unit becomes applicable. A subpanel with a main breaker must be installed inside the house to disconnect all ungrounded conductors serving the dwelling. In multi-family dwelling units, such as apartment buildings, each unit typically has its own electrical panel. The building's main service panel is often located in a common area. In this case, Article 408.16b wouldn't apply, as each apartment already has its own panel with a main breaker. However, if the building's main service panel were in a detached structure, each apartment would need a disconnecting means within the unit. Distinguishing between a disconnecting means and an overcurrent protection device is essential. A disconnecting means isolates a circuit from its power source, while an overcurrent protection device protects against excessive current flow. A main breaker serves both functions, but the primary focus of Article 408.16b is on providing a disconnecting means for safety. It is crucial to engage qualified and licensed electricians for all electrical work. Improper installations can lead to serious consequences. Professionals ensure compliance with the NEC and other regulations, guaranteeing a safe and compliant installation. When selecting a location for the subpanel, consider both accessibility and aesthetics. Utility rooms, basements, and closets are common choices. The panel should be securely mounted and protected from damage. Regular inspections are vital to ensure the electrical panel and breakers are in good working order. Look for signs of damage and test breakers periodically. Address any issues promptly by contacting a qualified electrician. Anticipating future electrical loads is also prudent. Selecting a breaker with a higher amperage rating can accommodate future additions and prevent frequent tripping. Always follow manufacturer's instructions when installing a subpanel and breakers. These instructions provide detailed guidance for safe and reliable installation. Grounding and bonding are critical for subpanels. Proper grounding provides a safe path for fault current, while bonding ensures no voltage difference between metal parts and the neutral conductor. Consider using FCIs and GFCIs in the subpanel. FCIs protect against fires caused by arcing faults, while GFCIs protect against electric shock. The NEC mandates their use in specific locations. In conclusion, the requirement for a main breaker and a remote panel is a vital safety measure. By understanding Article 408.16b and following best practices, you can ensure a safe and compliant electrical system. Always consult with qualified electricians for any electrical work. Let's delve deeper into the practical implications and specific scenarios related to Article 408.16b of the National Electrical Code. This regulation, which mandates a main breaker in remote panels under certain conditions, is a cornerstone of modern electrical safety, particularly in residential settings. Understanding its nuances is crucial for both homeowners and electrical professionals. One common scenario involves a homeowner who decides to build a detached workshop or studio on their property, separate from the main dwelling. If the electrical service for the workshop is extended from the main panel in the house and the homeowner chooses to relocate the main electrical panel to this detached structure, then Article 408.16b immediately comes into play. The homeowner is now obligated to install a subpanel inside the original dwelling unit, equipped with a main breaker that is capable of disconnecting all ungrounded conductors feeding the house. This is not merely a matter of convenience, it's a critical safety measure designed to ensure that occupants can quickly de-energize the home's electrical system in the event of an emergency, such as a fire in the workshop where the main panel is now located. Another scenario arises in multi-family dwellings such as apartment buildings or condominium complexes. In many such buildings, each individual unit has its own electrical panel, typically located within the unit itself. The main service panel for the entire building is often situated in a common area, such as a basement or an electrical room. In this configuration, Article 408.16b generally does not apply because each dwelling unit already possesses its own electrical panel with a main breaker located within its boundaries. However, if the main service panel for the entire building were to be located in a detached structure, such as a separate utility building or a detached garage, then the requirements of Article 408.16b would be triggered. In that case, each individual apartment or condominium unit would need to have its own disconnecting means located within the unit, ensuring that residents could quickly cut off power to their individual living spaces in an emergency. It's also essential to draw a clear distinction between a disconnecting means and an overcurrent protection device. While these two types of devices often coexist and may even be integrated into a single unit, they serve fundamentally different purposes. A disconnecting means is a device designed to completely isolate an electrical circuit or a piece of equipment from its source of power. Its primary function is to provide a safe and reliable way to de-energize the circuit for maintenance, repairs, or in emergency situations. An overcurrent protection device, on the other hand, is designed to protect an electrical circuit from excessive current flow. This excessive current can be caused by a variety of factors, such as short circuits, ground faults, or overloading of the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the flow of electricity when the current exceeds a predetermined threshold, thereby preventing damage to equipment and reducing the risk of fire or electrical shock. While a main breaker can serve as both a disconnecting means and an overcurrent protection device, it's important to recognize that Article 408.16b is primarily concerned with ensuring the availability of a readily accessible disconnecting means for safety purposes. The overcurrent protection function is secondary, although it's still crucial to ensure that the breaker is properly sized and rated to protect the panel and the circuits it serves. The importance of hiring qualified and licensed electricians for all electrical work cannot be overemphasized. Electrical work can be inherently dangerous, and improper or substandard installations can lead to serious consequences, including fire, electrical shock, and even death. A qualified electrician possesses the knowledge, skills, and experience necessary to perform electrical work safely and in compliance with all applicable codes and regulations. They will be familiar with the requirements of the National Electrical Code, as well as any local or regional codes that may apply. They will also be able to perform load calculations to ensure that the electrical system is properly sized to meet the demands of the building, and they will be able to identify and correct any potential safety hazards. When selecting a location for the subpanel and the main breaker inside the dwelling unit, it's important to consider both accessibility and aesthetics. The subpanel should be located in a place that is easily accessible in an emergency, so that occupants can quickly shut off the power if necessary. However, it's also desirable to choose a location that is relatively unobtrusive and that blends in well with the surrounding decor. Common locations for subpanels include utility rooms, basements, and closets. The subpanel should be mounted securely to the wall, and it should be protected from physical damage. It's also important to ensure that there is adequate clearance around the panel for access and maintenance. Regular inspection and maintenance of the electrical panel and breakers are essential for ensuring the continued safety and reliability of the electrical system. Homeowners should periodically inspect the panel for any signs of damage, such as corrosion, overheating, or loose connections. They should also test the breakers periodically to ensure that they trip properly when overloaded. If any problems are detected, a qualified electrician should be called in to perform repairs. When sizing the main breaker in the remote panel, it's important to consider the potential for future electrical loads. If you anticipate adding additional circuits or appliances in the future, it's wise to select a breaker with a higher amperage rating to accommodate the increased load. This will prevent the breaker from tripping frequently and will avoid the need to replace the breaker later on. When installing a subpanel and main breaker, it's essential to follow all manufacturers' instructions and recommendations. These instructions will provide detailed information on how to properly install and wire the panel and breakers, and they will help to ensure that the installation is safe and reliable. Proper grounding and bonding are critical for subpanels. The subpanel must be properly grounded to provide a safe path for fault current to flow back to the source, and it must be bonded to the neutral conductor to ensure that there is no voltage difference between the metal parts of the panel and the neutral conductor. Consider the use of arc fault circuit interrupters, or size, and ground fault circuit interrupters, or GFCIs, in the subpanel. SIs are designed to protect against fires caused by arcing faults in electrical wiring, and GFCIs are designed to protect against electric shock caused by ground faults. The National Electrical Code requires the use of SIs and GFCIs in certain locations, such as bedrooms, bathrooms, and kitchens. The safety and well-being of the resident is highly dependent upon the proper installation and maintenance.